Today we're going to talk about potential energy. Your objective is that students will be able to recite the equations and parameters of potential energy. And my daughter might talk on this a little bit.
Hi.
The definition of potential energy, one common definition, is that potential energy is defined as stored energy. If you think of batteries as storing electrical energy to use later, that's kind of a good way of thinking about it. Or if you pull back a rubber band and hold it, someone might kind of flinch because there's a lot of energy being stored in that stretched out rubber band. Another way to view potential energy is the ability of an object to do work. Basically, if something has a lot of potential energy, it has potential to do a lot of work. The more work an object or system has the ability to do, the more potential energy it has. So, a bigger rubber band has the potential to fly farther if you sling it. A bigger battery would have the potential to do more electrical work. One type of specific potential energy is gravitational potential energy. Gravitational potential energy on Earth is due to an object's position above the surface of the Earth. There's a couple different equations that we'll talk about. One is from the AP equation sheet. That's the one with the U in the front. Get my laser pointer on here. There we go. This one right here, the U equals mg delta y. So it's saying a change in potential energy is due to a change in height. So y is the height on there, and m and g are mass and acceleration of gravity like they've been. The book doesn't use U, it uses PEG. PE for potential energy, then the G underneath that meaning gravitational. It's called a laser pointer. Either way, delta U or PEG stand for potential energy. G stands for the acceleration due to gravity, and delta Y, or just Y, stand for the distance above the surface, or in other words, height, typically measured in meters. Units. The units for potential energy are joules, just like kinetic energy and work. They all have the same units, because to do work is to change the energy, so it's all the same stuff. Since doing work changes the energy of a system, it changes kinetic energy as well as potential energy. In other words, a change in energy equals work done, or work translates to a change in energy. Or the more AP way is that a change in potential energy, delta U, means work was done. Springs can also have potential energy. This is called sometimes elastic potential energy, or I'll call it the potential stored in the spring. But when a spring is displaced from its equilibrium x, the spring supplies a force F due to tension of the spring K, as in the equation F equals Kx, like we've already talked about in the previous unit. The spring force can have the potential to do work, so there's an equation for the potential energy stored in the spring. The one on the AP equation sheet is that you have the potential energy of the spring, or US, equal to 1/2 kx squared. Or the book will use PE with EL, meaning elastic potential energy. That's more cumbersome than the U, so I like the U from AP more. Either way, they both equal 1/2 kx squared. US and PEEL, or potential energies, stand for the potential energy in a spring measured in joules, just like all energy. The K stands for spring constant measured in newtons per meter, and X stands for displacement from equilibrium measured in meters, just like the spring stuff was before. And that's it for this time. Remember to use your notes to complete the online Edmodo quiz, and bring your notes with you tomorrow or next class to make sure that you can do as well on the open note quiz as you can. Thanks for watching. Say bye all.